So we're going to take some of the knowledge that we used this morning and we're going to try and make a project. So this is what I want to try and make. I want to have a 1/2 inch square bar, and through here I want to have a diamond hole and a round hole. So that would look over here. Something like that. Through this, I'd like to pass a ring of round, 1/2 inch round. So it comes through, sorry, like that. And this is going to have a corresponding diamond hole through here and through here. So when all said and done, what we should be able to do is pass a square bar on the diamond across there. And we should have 5 pass-throughs, is it? 1, 2, 3, 4, 5 pass-throughs in a short area. I'm hoping that this is going to be somewhere close to about 3.5 to 3 5/8 in diameter, ID. And we'll go from there. So the smaller you make these, the more sporty they get. If you make them big, there's a lot of slop in there. So as you go on, just try and get into that smaller target. First thing I'm going to do is try and punch this square bar. So you can see I've got 3 holes to make in fairly small area, about that sort of size. So what I'm going to do is I'm going to punch these 2 outer holes first and drift those, and then come to the middle. And the reason I do that is if I drift the middle, punch and drift the middle, when I'm punching and drifting this tends to sort of swing backwards and forwards and changes. So I'm going to leave this till later and then do these 2 and then, say, catch up with that one. So I've marked out my bar, hopefully correspondingly. Now, this hole, when we talked this morning, we said we want a 1/2 inch hole with a 1/2 inch bar going through it. So we've got basically a bar going through a 1/2 inch hole. But it doesn't look like that, does it? This is bent. So this is going to do this inside this hole. So you've got a gap here, and you would have a slight gap here. So this hole has to be oversized of that to allow the 1/2 inch hole, 1/2 inch bar to pass through when it's curved. And I'm thinking about 9/16 should get the job done. No, I've got one already made. Oh yeah, yeah. I mean that's of course.
Mark, you pre-laid this out already?
I hope so.
Yeah.
Yeah, we hope they're in the right place.
Did you talk a little bit how they are?
No, because if it's in the wrong place, I can fudge it.
Okay.
I will, James. Thank you. So when I punch a hole, I hit it once, look at it, is that where I want it to be? And in this case, it's not quite. And I'm going to punch from both sides, hopefully. So I lay out on the front of the bar. The back of the bar, I just wing it. Because I've got the swelling from the first punching that hopefully takes care of that. I'm going to wait for this just to cool down a little bit, and then I'm going to, hopefully that should give me a hole. Hole in the bar. to you. There we go. And it's somewhere near the middle. That's a change for me at the moment. This one, please.
Okay.
Then we're going to start looking at diamond drifts. I'm going to send this one around so you get to have a look at it before we make it. Because we're going to make a diamond hole. Oh, that's better, Nancy, thank you. So when I do this at home, so if you can imagine that every step I do is a piece of scrap bar going under the anvil. You know, I had this concept of something I wanted to do, and if you go to our library, or your library, and in there you'll see some Fritz Kuhn work, and you'll see some of his older work. He has this type of thing in a couple of gates. And I saw this a long time ago, and I thought, oh, I desperately want to make that. I'll try and follow him down this road. And every time I sort of went down the road, I just ended up going down a side street that was a dead end. And of course, that went underneath the anvil and start again. Thank you, James. So this is going to sound a little zenful, I suppose, but when I hit the tool, I'm not looking where the tool enters the bar. I'm trying to think or look through the bar where the tool's going to exit. And I'm trying to amend my holding position to reflect where that tool is going to exit the bar. Give me a warm up there, please. So this tool, you'll notice, isn't the same as my tool that I made this morning. This is made out of an air hardening steel, the H13 or the S7 sort of thing. And you'll notice that I don't forge the end, but you'll notice also it's quite soft. You know, and I should dress that, but I don't. I'll leave it there purely for demonstration purposes. It's not cracking. Plenty soft, and that's H13.
So, Mark, why did you make the other one out of 4130?
I make this one because it'll work a little longer before I have to dress it. So this is my sort of work that has to be accurate. That one is just sort of, let's throw it out there and make one that we can all use. That'll do it. That's good, James. Thank you. And now we're going to take a heat here and here and we'll drift those.
Mark,
Yeah.
how did you forge that taper so close to that soft end on that H13 without?
I'm going to bet, you know, I just tried to take the heat here and let the heat creep up. I just didn't stick it in, and so it was a warm-up heat rather than just a direct heat, if you like. But you're right, tricky.
You want to drift them at the same time?
I'm going to try. So we looked a little bit at angled holes this morning, you know, and I was drifting the angled hole over the vise, and if you were to look at the back of the hole, you'll see it being chewed up by the jaws of the vise. So that's not something you typically want to have in your work. So you would create a bolster. My bolster for that type of thing would look very similar to these two bits. Thank you, James. It did fit earlier, I swear. Let me rescue my tool.
Mark,
Yeah.
do you ever use like coal in the hole or graphite lubricant on your punches and such?
Yeah, certainly for deeper holes I do, and I just use coal or coke, whatever I've got available, but they're fine. And so if I'm drifting, again, if I was punching, I would punch, quench, the water then is somewhat sticky, put it in the coke ash or coal ash, now I've got the direct application, then go back to work. Same with the drift, I'd start the drifting, quench it if I had to, into the coke dust, the water will carry the coke into the hole to give me the lubricant, because it turns into that slippy graphite. I mean, coke is graphite, isn't it? Yeah. Thank you. I never was exposed to the various lubricants and things that are going around. That's not what we did, and we certainly punched enough holes. That side up, if you would. Thank you. So we just used the coal or coke ash, and we found that to be fine. That was all we needed. Thank you, James. Now, when I punch, there's a couple of things that can help me with that punch. You'll notice I'm pointing the punch into a direct source of light. Because if I'm working here, that light source is going to cast a shadow, and that shadow, I always end up crowding the shadow, so I end up with a thick side and a thin side. I'm going to take a bit more heat on that one, James, please. And so I like to orient the bar into the strong light source, whether it's electric or otherwise. Secondly, you notice I like to work along the bar rather than across the bar, for the same sort of reason. I don't come out, put the whole fast down and then come here, because now you sort of, where am I on that bar? I want to be able to look along that and say, yeah, I'm reasonably sure that's going to be in the middle. And then the other is, you ever put a center punch in the wrong place? Yeah. And so what do? You just crowd it, don't you, and move it into the right place. Well, you can do that with this. If you put this in the wrong place, hit it, look at it. If it's not where you want it to be, crowd it and put it in the right place. Thank you, James. I'm just using the swelling on the sides of the bar to landmark the tool. Hit it once, look at it, is that where you want it to be? Now it is. Just going to let that cool down a little bit. So I can get rid of that hanging chaff. There we go. Oh yes, so if it has colour, don't put it anywhere near the tank. If it has colour, don't put it in the tank. But if it's black heat, it'll be fine. Yeah. Is my diamond drift out? Or is it come back? No. Is it still out, diamond drift? Lovely, thank you.
Nice thing about your diamond drift is that it aligns you to a perfect diamond.
If the diamond drift is made correctly.
Yeah.
And we're going to talk about that.
Page 121, red book.
That's right. So Gerald Franklin here helped proofread that book, the Red Book. That's how we know. Thank you. So when I do this drifting, up till now you've seen me drift from one side only, yes? And just bang it through. And now you can see I'm starting to drift from two sides. Why is that? Well, now I'm starting to work over a bolster. So if I drift from one side only, I push some material out, and then maybe just a little bit of material comes out on the other side. Fine, typically not a problem. But in this case, because my drift and my bolster are really closely matched, that if I have a little bit sticking out and I push this through, I'm going to create a large amount of flashing. So if I don't want that, if I keep moving the mass back into the center by drifting from both sides, then I don't get the flashing. So you'll read, drift from two sides. That's what I think they're trying to tell you, is that if you're drifting over a precision hole, keep the mass, the excess mass, towards the center. Yeah.
Do you ever, like, upset before drift and drive the sides in?
Sorry?
Do you ever upset before you drive the sides in so that it swells?
Oh yeah, you can do that. And again, it's, what's the visual image that you're looking for when you're finished? Now, typically when you punch flat bar like this, I'm not so worried about it, because especially now, because I'm going to do a treatment to this in a minute. But if it was important to you, especially if you're punching through round bar or square bar across the corners, then you want to give it a little pooch. Thank you. This stuff keeps me awake at night. There we go. So there's my diamond hole, not finished, but there's the start of my diamond hole. I'll tell you what, let me put it here. And you can see it's round on the outside and not looking very pretty. So I have a couple of things I can do. I can come here and dress that which typically I would do for my first one if I was making a set of tools, or if I had the tools made, which I do. I think that's fine. Thank you, James. I can pop that in there, put that on there. And now I'm starting to true up that hole. And so if we put that to the camera, you can start to see that that's starting to look a better hole. Yeah. The last thing I do, just a very light heat, please. So if we look at a diamond hole, and let's have a look at some of its attributes. Here's my diamond hole. You can see I've got two different sides. Let's get rid of this one. So if that's 1/4 inch and that's 1/4 inch, what's that? If that's 1/4 inch and 1/4 inch, what's that? This top one would be 1/4 inch or thereabouts. This one is going to be in excess of 1/4 inch, isn't it? And I didn't have that. I had my 1/4 inch material. So I can't get that without a loss of fussing around. I can get this one. So what I do, thank you. Just going to straighten this out a little bit. Pop that in there. And then the last thing I'm going to do is come here and just flatten those edges up a little bit. And that should give me now something that is reasonably pretty, shall we say. If I look at that now, that starts to be a little better, doesn't it, and visually? Yeah, it's just cleaned it up a little bit. And it's not perfect, but it just gives me the essence of a straight wall here and a straight top. And if things have gone reasonably well, I should have about 3 5/8 between the edges of the hole. So if I'm looking at from this edge here to this edge here, I should be about 3 5/8. And I'm about there, I think. Can you see that? Let me chalk that up and you can see it. I want 3 5/8 centre to centre. Well, centre to centre is hard to measure, but edge to edge is fairly easy to do, and it's the same measurement, right? So you can see that's about 3 5/8 edge to edge. And so the middle, I compensated for any stretch, shrinkage, or remained the same in my layout, and it looks like it's about right, 3 5/8. That's what I wanted, and I said I wanted that 3 5/8 centre to centre for the hole. So that bit's looking all right. All right, now let's move on to the ring, because the ring starts getting a bit complicated. Firstly, I want you to note that the ring is made out of round bar. That's what Fritz Kuhn used. And you have to think that he's leaving me clues. Every time he tells me something, he's got these clues. And all I've got to do is understand them. Round bar. What do we know? What is the attribute of round bar? A strong attribute.
Don't have to worry about twisting.
We don't have to worry about twisting. Okay? So I look at that round bar and I thought, round bar, maybe he twisted somewhere. I'll put that, just in case things aren't going well, I'll remember that later. Okay? So let's have a look at this. I want, when finished, a round bar with 2 diamond holes in it. Okay, no problem with that. So I've got a square bar with 2 round holes and a diamond hole. Okay, well this has got to fit through these 2 holes before I punch the last one. I can punch 1, I can't punch 2 because it's not going to fit through this hole, is it? So that punching has to be done afterwards. Okay, so let's have a look at what that might look like. Here's my square bar, and I've got through, and I want to punch. Now don't forget, this one's been punched. Here's my diamond hole. Okay, and this is how I would hold the bar. Remember, I'm sticking it between my legs. I've got this bar, and I want to punch the second hole. So what have I got to do? I know it's got to come from here, okay, which is, when you look at the anvil, is punching here, like this. Is that going to work for us? No, not really. Now I can get there. I could take all this, drop that, stand by the side of the anvil, put a pair of tongs on here and punch that way, provided I can get to the support, a half round, to hold that as I punch. Well, that just seems, I got this, that, I've got a piece in there, this bit's what, that doesn't seem like that's a winner either. Yeah, I'm not happy about that one either. Ah, the twist. Well, why don't we punch it here where we can see everything and twist it into alignment? Good idea. That's what we'll do. So that's why I used round bar. That was the first thing. But that's further complicated. We want to do a forge weld. And so when we look at this, we've got a scarf on one end and a scarf on the other end, but we're twisting this end. Well, that doesn't sound good. So we're going to twist, you know, when we put these, typically when we do a scarf, we've got one scarf here, and we've got another scarf here, and they typically face the sort of opposite directions, don't they? Yeah? Well, we're going to twist this one 90 degrees. So if we do this to start off with, this one is going to be oriented 90 degrees to its correct way. So we can't do that. So we're going to have to make the scarves 90 degrees to each other and then twist those into alignment. This is starting to become a nightmare. Okay, so we need to remember where this is and how to twist that, so at least we get it twisted into alignment and not back to front. we don't want that. So we've got to twist it the right way. So we know we can twist it the wrong way. So that's something, put a little note on the anvil, twist bar right way, So we're going to try and do that. Yeah, and then we have to do, if we're going to do an upset of these, which we really should if we're going to do a forge weld, then we have to do that now because it's going to be really hard holding that and doing an upset unless we've got a vise that will fit in that little bit, and that's not a very long bar. So I don't think that's going to work, so we've got to do our upset first. Okay, well, let's get this in order. First of all, let's have a look at forge welding. We did all that chain welding last night, or we had to go at it anyway. What do we know about forge welding? Let's do this. If I want to put these two bars together, in which direction would the hammer blows come from? No trick questions. From the elbows, right? If I want to put these two bars together, in which direction will the hammer blows come? Top and bottom. Okay, so let's draw a conclusion with that. Let's say that the force applied is 90 degrees to the welding surface. Force applied is 90 degrees to the welding surface. If I put these two bars together and hit them from the top and the bottom, is that going to make a union? No. If I put these two bars together and hit them from the elbows, is that going to make a union? No. Okay, so we've got something we can use. We've got to hit these things 90 degrees to the welding surface. Secondly is, again, we start looking at inertia, or a bar's ability to act as its own anvil. If I take, let's be extreme, let's take a 4 by 4 inch bar, 1 foot long, big bar, yeah? I've got it all hot as you like, I don't care. And I've got it hanging horizontally from a little wire from the roof. It's all hot. And I come along with my hammer and I hit one end. Will that end be deformed? Yes, because the inertia of the bar is going to act as the anvil. Will the other end be deformed? No. Okay, so even though a bar is all hot, it can act as its own anvil. We just said one end can be deformed. We need an anvil to get that deformation, don't we? The inertia of its bar can act as an own anvil without changing the other end. So what do we know about forge welding? Do we come from West Hell to make the union, or is it small rapid blows? Small rapid blows, okay? So what are the 4 factors that affect the penetration of your hammer blow into a piece of steel? First is, how hard are you hitting? If you're just hitting lightly, you're only going to affect the outside edge, and we saw that yesterday with the upsetting of the outside edge, hitting lightly and rapidly just to make a change and not taking that into the center. Secondly, if I ask you to put a point on a piece of 1/2 inch square bar, you say no problem. If I say do it cold, that presents as a problem. So heat must be a factor of the penetration of your hammer blow. Third would be, what is the nature of the material that you're using? Are you using an aluminum, copper? Are you using a stainless steel? All of those will behave differently. You've got to really give stainless steel a bit of a biff to make it work. Yeah? So you've got how hard are you hitting? How hot is the material? What is the nature of the material? And the last thing would be the location of your hammer blow. And this is sort of getting back to physics now. So if I come here and I hit in the middle of a bar, I have resistance to my hammer blow 360 degrees around the hammer. Agreed? If I come here, I've got half that resistance, have I not? I've only got resistance on 180 degrees. This is hanging into space.
Which is going to make a step, right?
Which would make a step. Okay, ready for the next one. If this were a 1 pound hammer and this were a 1 square inch face, how many pounds of pressure is that going to apply? 1 pound per square inch of pressure. How much pressure is it applying here?
2 pounds. Still 1 pound per square inch, but 2 pounds of pressure.
2 pounds of pressure, exactly. So I've got half the resistance and I've got twice the pressure. That seems something I can use. Okay, so now let's go back to our bar. We're going to hit this with light blows, and we said that one of the factors that affects your penetration is hard blows. If you hit it lightly, you're only going to affect a top surface. So if you hit this with light blows, which we know we need, the top surface is going to spread. The bottom surface, because we know we can hit a bar and it can act as its own anvil, even though it's all hot, the bottom surface is going to act as an anvil, the bottom piece. So you get the top surface is spreading because the light rapid blows, and the bottom piece is acts as an anvil because it's not being hit by penetrating blows. So what that happens is you start getting the wings on the edge of your scarf or the weld. Have you seen that? Yeah. So if you don't want those, because they're a little bugger, you can't get, you have to file them off. They won't weld in. They don't carry the heat from the forge. They're terrible. If you don't want those, then make the bar narrower than the bar to which you're going to weld. And then as you start to make your light rapid blows, it will spread hopefully no wider than the bar to which you're welding. So we've got two things. We know we're going to hit 90 degrees. We know we're going to have the bar narrower than the bar to which we're going to weld. But let's have a look at this again. Okay, we know we're going to hit 90 degrees. This bar, this end of the bar, is that in a welding plane or in a slip plane or a shear plane? It's in a shear plane. Okay, so if we want that to weld, it's got to have a slope on it, doesn't it? Okay, so we've got force applied, 90 degrees, slope to the end of the bar to put it in a welding plane, and the end of the bar has to be narrower than the bar to which you intend to weld. It's rather long-winded, wasn't it? So we're going to take this and we are going to take a very low heat and we're going to do an upset. And hang on a moment, we're going to do that on the long end first. So this is what I've got. So again, think trial and error. I've already made a couple of these and it's not gone well. So now what I'm doing is I've progressed a little bit and I want to do the forge weld to make this whole thing come up. So I've got my bar. I've got this coming through like that. And I want to make a forge weld just about here. I've got my punch here, this hole here, okay? And you can see that hopefully that bar and this bar are even lengths. Can you see that roughly? But can you see where that puts the weld? Right here in an awkward spot. I can't make that bulge. I mean, I'd like that here in the middle to push this bit of bar here so I can get that weld in the middle of the bar. It's not going to happen. So the way to do that is when I do my layout of my bar, there's center line, okay, I come here and there's one hole, and everything is even. That's not going to work. So I need to come over here, move center line, and then move my holes. So I have a long side and a short side, and I'm going to have a long side coming through here and the short side on this side, and that's going to give me a weld that's going to be more in the center of the bar. That I can get to with a heat and I can get to with my hammer. And that offset, if I move this ½ an inch, it makes 1 inch of difference. Do you understand that? So let's say this is 3 inches either side. If I come this way, 3 inches minus ½ an inch, 2½ inches. This is 3 inches plus ½ an inch, 3½ inches, difference of 1 inch. Yeah, so I'm just moving it ½ an inch. Oh, beautiful. Do you use those for doing your upsets for your scarf? We're going to quench that and we're going to do the same thing on this end. Why do we upset a scarf prior to welding? It's a general question.
More mass.
More mass for what?
For forging your weld back to where it should be.
So you don't get a waste after you've done the weld.
Let's have a look at that. So your scarf may be different to my scarf, but it's going to look very, if you can agree with me in principle. That's it, like that. So we've got almost twice the bar thickness in the weld area. Do we need any more? as I've drawn it. Yes, no, indifferent? No, we don't. Okay, because we've got enough here. Let's have a look here. What's happening here and here? We've got the same scaling welding heat that we need up here, because it's going to be in the weld, and we're going to try and blend the toe of the scarf in with our great big hammer, okay, and not thin this bar. Yeah. So this is where we want the upset. We want to create a little bulge here so we can, one, it will resist the scaling heat of the weld, and two, it will resist the hammer as I blend in the toe of the scarf. That's where I want the upset, is here and here. I don't need any more material here. Does that make sense? So when I take my little V and I bang, here's my bar, and I bang that in, what happens? Where's the upset? Right where I want it, yeah? And I've started to form my little point on the end of the bar. Bar is narrower than the bar to which I'm going to weld to. Yeah? So we used to do this just in the step of the anvil. But lovely, thank you. So you notice I'm being fairly choosy here. I am making sure that my flats are 90 degrees or in line with my center punch marks for my hole. Okay, so if we have a look at this, actually, sorry, let me do this. I keep forgetting about the camera. You can see I already started to form my scarf, and I've got the upset back behind the scarf, right? And that's what I'm after, in both directions. Now I'm going to stay here, and we're going to make this scarf. So we can take a general heat. You'll notice my tool has the V offset from the center. So I have the V for my scarf, and I have a little table here. So when I make my scarf, when I'm dressing down the toe of the scarf, I can ding this surface up as I'm trying to thin the toe down, rather than ding my anvil up doing the same thing. I much prefer to ding this up than this, although this isn't my anvil, so it doesn't really matter, right? But you know, somebody cares. So that's why the table. Thank you. Okay, so I'm starting to make my scarf. I'm going to keep it reasonably short. I'm going to put a step in there. Take another heat there, James. Now, making the scarf's got a slope in it. The bar is narrower in the end to the bar to which I'm going to weld. Is the scarf, once I've done the step, will the scarf be finished? For the same reason. We formed a square taper. Those corners are proud of the main body, and they're probably not going to fit through that little hole, are they? Thank you, James. I'm just going to pop that in, and I want about 3/8 of an inch or so. So I form a slight step, and come down, chase that end down, and now I'm going to come here, and I'm just going to knock those corners off, exactly as I did with the 1/2 inch round drift this morning, in the hopes that that will fit through my oversized 9/16 hole, okay, and allow me, so you can see I've still got the upset. Now, let me see. Yeah, it's going to be very subtle. Can you see I've still got an upset, hopefully, behind the scarf, and it fits through, where are we? There we go, the hole. There we go, sorry, that's it. We're going to quench this. We're going to do the same on that end. A lot on backwards and forwards. Again, think of every time we're doing a step, just think of another piece of scrap going under the forge. Oh, right, I forgot that bit. Start again. But I desperately wanted to be able to do this. I'd seen this in Fritz Kuhn, I'd seen it in other work. And I desperately wanted this to be mine. I'm just going to try and file this a little bit. Let me know, James, when you're ready. Stay there, be fine. Thank you, James. You can see me twiddling the bar around. I want to make sure that my scarf is following my center punch marks. Same again, please, James. Do you make your own bottom tools? Have you done that? So when I was starting off as a baby blacksmith, you know, you'd go out and either go to Vaughan's, who were the operators of the day, and buy these sort of things, or you go down the antique market and find them, and they'd be, you know, I don't know, £10, $15 or something like that, and they may or may not have the one you want, or you can make them. Thank you. Yeah, and that's what it comes down to. You know, you can buy them for 15, or you can make them in your own shop for around about 100. Yeah. That's what it's like in my shop, anyway. Go no-go gauge, fits through those. Okay, that's handy. And now let's have a look at that. And you'll see that this scarf is not aligned with the other scarf. Can you see that? Can you get that, Carl? So this scarf is aligned this way. This scarf is aligned this way. So they're 90 degrees from being correct. But so are the holes. We know we're going to twist one hole to get it right. So we'll twist the scarf with it, and hopefully we'll twist it the right way. Again, note on anvil, twist hole right way. Okay, so they align and we can go to weld plating later. Okay, we want you see the center punch mark down there? We're going to punch that. You see that?
Right there,
Yeah. It's in now. Yes.
What are you going to use to get a grip on the round stock to twist it 90 degrees?
I'm going to stick, because it's going to have a hole in it, so I can just stick a bar in it. Yeah, quite. Yeah. Yeah, again, you know, another piece under the forge. Yeah. So let's have a look at punching, just while James is taking a heat there. And let's punch 3 shapes of metal. We've been doing the easy one thus far. You know, we've got square or flat bar. When you punch it, is reasonably stable either side of the punch, isn't it? It's not really going anywhere. You might suck a little bit down into the hole, but it's not really going anywhere. Well then, let's have a look at round bar. When you punch it, how much support do you have either side of the punch right there? Very little. Yep. So you know that that punch is going to pull this material down until it finds sufficient resistance here to resist the punch. And you'll see a little divot in your work. If you don't want the divot, then you're going to have to upset it prior to doing the punching. Okay? So, but that's important for me. Let's go one step and then we'll come back to this. And then we'll go to diamond shape. And again, how much resistance here is there to your punch? None at all. It's fresh air. So this is really going to be deformed. So if we know it's going to be deformed, why don't we deform it before that and use that to our advantage? So if I take a piece of round bar and I lightly run here's my center punch mark, and I lightly run my hammer on the surface, do I not create a bit of a flat? And the flat has 2 parallel sides. And are not those parallel sides parallel to the center line? And would not my slot punch fit right in the middle of those and look ever so nice and be parallel to the center line? So why don't I use that? I know it's going to be deformed anyway, so why don't I use it? Yeah, same with this. Why don't I just come in and knock that off a little bit and be left with some training wheels that I can park my punch in and go to work? Just throwing that out there. Thank you, James. I'm just looking at that outside surface to get my reference mark for the back punch. Hit it, look at it, is that where you want it to be? I'm going to take another heat on that, James, if you don't mind. So I'm more into this bar, you know, 2 upsets, 2 scarves, things like that. I'm into this bar for a little bit of time, so I don't want to make a mess of this. It's not like, say, oh, I'll make another hole. No. So I'm going to take my time with this. Mando, would you have a look on that shelf? Find me a bit of half-inch square bar, something like 2 foot long or close enough. Thank you. That should be releasing, and you can see there's my slug. Can you see the bulge on either side of the bar? That's what I use when I park my slot punch. I park that in between that bulge around there. That's inconvenient. There we go. Here's my tongs. There we go. Just a light heat and we're going to knock that slug out. Fine. Lovely. Just going to let that cool down a little bit. And I'm going to find my punch. Where will I put that? Are the planets not aligned today? Is there something going on that I don't know about?
The moon's aligning between us.
Something going on. So what James is taking particular care with is making sure that the hole now is oriented vertically in the fire. He's not putting the hole down either side, because if he does that, he's going to take a heat on one side, the hole is going to act as an insulator, or the air in the hole, and I'd have less of a heat on the other side, which is fine. If that was the way that it worked, if I punched the hole and I had a thin side and a thick side, well, maybe we would look at it that way. But as this is reasonably, sorry James, one more time. Found one? Yeah. Lovely, thank you. Thank you very much. Okay, now what I want for you to see, can you see this slight bit of flashing or rag? See the shiny spots? Yeah, just on the corner? They were the bits that got pushed down into the hole and caused into flashing. So even though I was drifting from both sides, I still got a little bit of flashing. Think what it would have been like if I'd only drifted from one side. Yeah. All right, we want a heat, if we can, sort of there. Try and avoid the heat around the hole if we can.
From the hole forward?
From the hole forwards.
Okay.
No, that should do it, I think. Be fine. Well, what I'm going to try and do now is just pull that around. Okay, so we've done that bit. Now we're going to do from the hole back, but not too much.
So that block you put in there is just to set the height on the cone?
It just helps me keep it up near the top instead of falling all the way down.
You stay right at the top of the tube?
I stay where I think is appropriate. Again, you know, it's a sliding scale because, okay, let's step backwards. What's our final outcome? 3 5/8, right? Well, what did we do? The first step we did to this ring was what? Upset the end. So now it's no longer the same length, is it? So my 3 5/8 diameter is correct for a certain amount of that. So if I want the correct radius, I'm going to have to move up and down this cone to reflect that shortening or lengthening of the bar. Thank you. Hopefully that still fits. Yeah. So now what I can do here is trap this side, and maybe I can do this with the tongs, and then just pull this side around, and I'm aiming to be slightly more than a half circle. There we go. Like that. And hopefully that will still come out of there. Just let me fuss with this a little bit. There we go. Now, if things have gone well, and they seldom do, of course, you can see that that and that don't fit. James, can we Switch to James, I think. There we go, we'll do it with Carl, is that you?
Yep.
Okay. But if I take this, move that to the side, rock it back, so in a bit of a radius, that now starts to fit. Yeah. I'm not going to do that way. You have to hit this end. Can't hit that because you're just straight. Sorry. There you go. Maybe we'll go with that way, I don't know. It's a lot easier if I have the straight bar on the top hole.
Straight bar, where it was?
Hang on. Coming out to the top hole rather than the bottom. Maybe we just go with what we got. Not quite sure what to do here. There we go. Thank goodness. I have done this before. Do that, do that, do that, that. So hopefully now if you look at that as well, you can start to see, I hope, that those holes are starting to line up. That's you, James.
Yeah.
Yeah. So that's what we got. So now what we're going to do, so if I hold this here, so I want to punch now here, right from the top, put this between my legs, punch. And you can see I have the center punch mark here. Got it? Can you see the center punch mark?
Show us again.
It's right there. Yeah. So it's on the top surface, but it's not in line with this. That gives me the ability now to, once I find my tool, there we go, come in here, hold that, and punch that this way. Now, I said this morning that punching across the bar is not my favourite thing to do because I always end up crowding one side or the other. In this case, I don't really have the choice. If I had a Smith and striker, I could work this way, put my tool on, and have the striker work on the other side. But they don't. It's just me. You know, that's what I do in my shop. Probably the same as you in your shop. Okay, so we are going to take a heat just there.
Have you tried punching that, collapsing it, slipping it through the hole?
I'm sorry?
Have you tried punching that, collapsing it back and sliding it through the hole?
Yeah, that doesn't work because you've got some swelling, and then opening it backwards and forwards. It's just going to look like it's been worried, and I'm trying to avoid that. That's what I'm looking for. So we have 10 minutes, is that correct? Quarter till? 11:45 is what we get, is that, yeah. So what I want to do is I want to leave a bit of the demo for tomorrow when more people come and do this weld up and do the final thing, because, you know, rah-rah. So I'm going to punch this hole, maybe drift it, and then we'll stop, and then we'll start looking maybe the last tool, that diamond drift, and leave the welding of this till tomorrow. Yep. Doing this on purpose, I want a little something that's going to support that material that's out to the side and try and just stop it bobbling around too badly. It's going to bobble anyway, but I'm trying to keep... How are we doing? Good? Very nice, James. It's nice heat. Let's make sure I've got the right center punch. Come on there, and I'm going to hit it. Is that where I want it to be? It's close enough. One more. I'm going to give it back to James. And again, you'll notice I'm being a little careful with this because now I've got a bit of time in this and I don't really want to make a mess of this hole. Yeah. Same please, James. That was very good before. Lovely. Thank you, James.
Ready?
Yep. If anybody's breathing, tell them not to. And then we should have a slug coming out. We're just going to do that just once more. Finish that slug. Hole in the bar, somewhere near the middle. Yeah. So let's drift this and then we'll maybe call it good. We'll put that bit of round bar. I'm going to start the drift here. Don't forget I've got that swelling from the other drift sticking proud, so I can't just put the whole thing flat on the anvil and go to work. I'm going to lift it up, start it here, capture, and then hopefully drift.
Okay.
Lovely, thank you. Thank you. So fussy, yeah? I mean, going to do this for a job? No, thank you. But in terms of, you know, the games we play as we become blacksmiths, and I'm still learning to be a blacksmith, you know, I'm a baby blacksmith. When I stand here, I'm practicing, you know, I'm doing the same as you guys, you know, trying to work it out. And so I saw this, and it was a game I wanted to play. It was something I thought, I want to try that because I'm sure it will teach me something. And it did. Some of it I was ready to learn, some of it I didn't really want to know. Okay, that's that bit. Now, Jax, this one is the money one. We want to heat between this ring and as
Okay.
far up there as you can. And we can quench this.
Okay.
So if it runs into the hole, that'll be fine. Yes, sir.
Do you need this part here?
Sorry?
Do you need this part here?
I'm going to use that right now, so if we can move it out of the way. All right, remember note on the anvil? What did the note say? Twist bar right way. Twist bar right way. Don't confuse it now, Scott. No. That'd be a bad thing. See a grown man cry? And again, just think of every step as a piece under the anvil. You know, I had a pile like this that was just collecting there as I was making all these mistakes and learning from them and firing them under the anvil and start again. That's going to do it. See if we can convince that to fit in there. Yes, we can. Now we're going to twist this right way. That's going to be that way, right? So they're both facing the same direction. Is that correct? Yeah, so when that one comes round, it should land on top of that. Yeah, that's what I want. Good. Cross out thing on anvil. Yeah. Sorry? A little more? That's it. So that was why Fritz Kuhn started with round bar. So he could do that little move and pull it around. That's where I'm going to stop today because I'm going to quit while the going's good. And it's 11:45, is that right? Oh, sorry, we've got a bit more. Okay. 11:45 by my watch, not by your watch. Okay. 4 minutes. So let's have a look at the diamond drift. We are done with that. The diamond drift. I'm going to put this here. Can you see that? So let's have a look at some of the attributes of this drift. You can see that it has a flat surface here. Those two flat surfaces that taper to the working end of the drift, which is here, the working end. Those flats have to be parallel with the corner-to-corner dimension. If they're not, when you put that tool in the slot punch, those corner-to-corners are going to be pointing to wherever your difference is, and they will always go that way. And you will always have holes that are not in the right place. So when you forge this, you need to forge this down to make sure that those two flats are parallel to the corner to corner. Now, if you're like me, I have a slight angle to my hammer. My hammer doesn't hit flat, my hammer has a slight lift on the heel. And I've tried to get rid of it and I can't do it. So I know it's coming. So all I do is I leave myself a little bit of room to come in there with a file and catch that and bring it back to that flat to flat, corner to corner measurement. So let me just make one off the end of a bar quickly. Sorry. And then, do you remember when you were learning blacksmithing, they said, make a taper and I want the end of the bar to be in the center of the bar, at the end of the taper to be in the center of the bar. Do you remember that? Not off to one side. I'm going to show you why now. So typically, when I make these, and these are a money item, you can see it does a lot of work. So I like to make them out of tool steel. I don't like upsetting tool steel if I can avoid it. Why not? Get back to that. So what I do is I take a bit of tool steel, draw it down to my upset half-inch measurement, then I make the drift from it. Iron, and I'm talking about iron, iron has a blue brittle range. We've heard this in the folklore of blacksmithing saying a blacksmith will go to hell for one of two reasons. One, not charging enough, and two, hitting cold iron. Why? What's happening? In iron, there is the blue brittle range. It's a temperature range of about 350 degrees to about 700 degrees, a black heat, and in that range of heat, iron, which makes up 90 percentile of steel, iron is brittle, thus blue brittle range. Okay, so I use chrome molybdenum for my tool steel because it's readily available to me. Chromium, the presence of chromium in a bar, exacerbates or makes worse the blue brittle range, or the effects of the blue brittle range. Okay, that's the first thing. So, if I want to upset a drift, as I did earlier, first thing I did was I came out, I had my half-inch round bar, it was all hot, I quenched that, and I upset that bit. Did I not? Can we do that with the tool steel? No, because when we quench that, we make it hard and brittle, and we can't go around beating it, so we have to do it another way. Okay, we could do it another way. We've got oxyacetylene with a rosebud, fine. So now let's heat this and leave these two ends cold. So if we've achieved the same thing as quench, right? All right, this is cold, this is hot. What's this? Is this a gradient in temperature? Somewhere along that gradient is 300 to 700 degrees Fahrenheit. What is blue brittle range?
3 to 7.
3, yeah. So are we not hitting chromolybdenum, which exacerbates the blue brittle effects in its range? Yes, we are. Even though this is hot and that's cold, we've not quenched it. That's why I don't like upsetting tool steel. I do, but I don't like it. So if I upset tool steel, typically I'm going to have a bar, and I'm going to have the end hot, and my blow is going to come from the hot end, and it's decreasing as this changes shape. My hammer energy is decreasing, so I've got only a very small amount of energy in here. So I've got a small amount of energy in the blue brittle range. What I don't do, or try not to do, is have the heat here and hit here, because my maximum energy is coming through the blue brittle range. I don't enjoy that. Yeah. So if I'm going to upset tool steel, and if I can, all of these are parameters, it's not an absolute, then I will, if I can, hit from the hot end using the energy through the hot piece. It's being depleted as this is changing shape, and hopefully when it gets down to here, I've got minimum force in the blue brittle range. The way to get around that, start with a bigger bar, draw it down, rover size, go to work. Yeah? Thank you, James. Lovely. You're going to take that a bit more? So this is just a bit of half-inch mild steel. All I'm doing is making a token gesture of making this drift, just so you see how I make it. And I use these, I punch angle holes with these, so I can have a square bar on the diamond going through a square bar on the diamond at the angle. And it's in the red book, if you want to have a look at it in the red book. How about I make this one badly, because it'll really show what I'm trying to do. So what I'm going to do, the taper, you see I'm dropping my hand, you can see the taper is not on the middle, is it? It's off to one side. Can you see that? And that's not correct. Don't do that. When you make this, we're going to make it with the taper on the center line. Let me see here, what do I want to do? Yeah. So I drew that down to about 5/16 or so at the end. Again, when we squash that, because we're going to squash it here because we want a nice deliberate taper, cow poop says it's going to grow both directions, and it hopefully should grow to no wider than the dimension between the corner and corner of the actual main body of the drift. That's lovely, James. Thank you. So I've got my offset going this way, and now I'm just going to so a couple of things. Firstly, the edge. There you go. Can you see, that's it. Can you see that corner near the working end, just down here? The corner is not in the middle of the bar. I've got a thick side, which I think is the top side, and then a thin side, which is the bottom side. And that's the slope of the hammer. My hammer, I was telling you, that's my slope. Okay, and it's going to be the same on the other side. But I can compensate for that by firework. Now, this wasn't too bad, but can you see that the end is slightly off-centered? This is where it was not correct. And so how do I get it back on center now?
Hold the hammer in the other hand.
Yeah, but if I hit this now, yeah, I'm just going to damage that edge, and I need that edge to be able to go to work. So when you do the taper, when you do the initial taper, make sure that the end is in the center of the bar, so when you flatten it, there's no correction needed to get it back into the middle to make this tool do its job, because the correction is just going to make a mess of that corner.
You can make a tool to fix the tool.
You could make a tool to fix the tool, of course you could. You can always do that. And then we'll, I don't know, cut it off somewhere here. I'll take a hot cut to it. Do we have a hot rasp? Hot rasp? Lovely. Thank you. Thank you, James. First thing I'm going to do is just rasp and file this. And I'm aligning the rasp to the main body of the drift and then running it down. And it's going to get rid of the bit of swelling there. I'm just going to do one side and leave you to see the other side. I'm hoping you can see, there we go, the one side, the side I just filed, is reasonably straight, and there's a bulge just here on the other side. Can you see that?
Yeah,
And
could
that-
you use that bulge as your upset, and, because you want plus plus?
Yeah, but it has to be in the main body. It's just two-dimensional. I want three-dimensional, the other axis as well as. But yeah, I can see that. Just there,
One more
James.
heat to cut
Yes,
it.
one more heat to cut it, with a bit of luck. Close, done. Yeah, one heat, done. When I was looking at the angled holes, I was talking about the bolster plates. You know, if we've got a hole that's going through a bar and we want to drift it, it'd be nice if we had something here with an angled hole that we could hold other than using the vise. Remember how I said I got the chatter line to the vise? So the way I deal with that is I take a large block of steel, and large to me would be sort of 2 by 2, something like that, and I drill a large hole, a non-disclosed large hole. It's whatever is appropriate to the diamond that you're making. And I drill that in there, and then I take this to my saw and I cut that at whatever angle I want. And when I take this and hold it horizontally, it has a hole set at the right angle. And that's what I can use, those two bits that went round, that's what I use to make my bolsters. So I don't need a mill or anything like that, I just need a drill press. Thank you. And all we're going to do is draw a taper to this. If you want to go to lunch, fine. If you want to stay in the hot this, be fine. Thank you, James. Okay, and there's my taper to the struck end. You notice I gave myself a long taper because I'll use these when making diamond pass-throughs on the diamond through the angle. We're done, James. Thank you.
Thank you.
Thank you. And so to do that, again, I take the same sort of 2-inch block. And I basically, let me go in here. I come in, I cut a V in it, so if we look at the end, it's going to look like that. So I can capture the square bar, okay, so it's not going to deform. And then in this, if I look at this plane, here's my bottom of my V. I'll come in with a punch, blacksmith's round punch, and I'll just punch a slight flat in here, the normal blacksmith's round punch, and I do that at approximately the angle I want. Let's call it 30 degrees. So now what I can do, when I put this up in the vise, the pillar vise for the drill, I can hold this at the appropriate angle in the vise. Here's my dotted line. Here's my bit that I did with my punch. Okay, and you can see the drill now can come on and has somewhere flat to go on as opposed to being pushed down a V slot. Yeah, and I just drill that and then drift it. So I've got, and I'll remove a bit of this. I've got this hole in here that I've drifted, and I need that extra length to be able to bang all the way through to get to clear the material. Okay, that's why I did a long tape on that. So I used my drifts in two places, this angled one and the normal perpendicular one. Okay, thank you very much. Enjoy your lunch. I'll see you tomorrow.